going to talk about logarithm equations. So this is the extension of 3.4A, which was exponential equations. And so we're going to follow some rules to help us out with that. So objective, it says apply the one-to-one property of logarithmic functions to solve the equation. So basically, we want to do the same thing to both sides in order to solve the equation. And so we're going to, instead of giving it a log, we're going to give it a base. And you can see that that's actually what's happening in this example at the top, is that they've taken log base 2 of x equals 3. And since the base is 2 on the log, they've let those parts on the left and the right be exponents, and they've given a base of 2, because a base of 2 and then an exponent with a log of 2 will result in just x. So we're going to do the similar kind of thing here for this guy. So in example A, we've got natural log of x equals 6. So keep in mind that the natural log of x is exactly the same thing as log base e of x equals 6. And since the base of the log is e, I'm going to create an exponential out of this using a base of e as well. So I'm going to add an e here and an e here, and the log base e of x and the 6 both become exponents. So on the left side, when I have e to the log base e of x, that simplifies to x. And then I have e to the 6. At that point, I'm going to get out my handy dandy calculator, and I'm going to find out exactly what that equals. Give us a minute here. And so I'm going to go e to the x and then just do a 6. And that says it's going to be about 403.43. And so there is my answer. All right, for B, we're going to do a similar thing, except we have to solve for the log first. So I'm going to subtract 6 from both sides, and I have 2 log 5x equals 12. And then I'm going to divide by 2. So then now I have log of 5x equals 6. Okay. Remember that is a log base 10. I'm going to come up here because I'm kind of running out of a little bit of room here. We'll have log of 5x equals 6. And then since this is log base 10, I'm going to put a base of 10 when I write this exponentially. The result is going to be 5x equals 10 to the 6th. And we're going to divide by 5. So x is going to equal 10 to the 6th divided by 5. And again, we can use our calculator to find out what that's going to be. And I get 200,000. For C, I'm sure you can guess what we're going to do for that one. We already have a log, it's solved for a log. What we can do though here is we're going to write that without an exponent first. So I'm going to say I'm going to bring the 3 down. I'm going to say 3 log 8, base 8 of x, equals 12. And now I can divide by 3. And I have now log base 8 of x equals 4. Okay, now I've got something to work with. So I'm going to, because I have log base 8, I'm going to make 8 as my base. And that leaves me with x equals 8 to the 4th. And we'll see how much that is. $4,096. So hopefully you get the idea there. All right, for our next one, we have another log here, and what we want to do is we want to compress it. So I have log base 4 of x, and I'm going to compress this right side so I have a log on both sides. Addition is going to be multiplication, so that would be log base 4 of 3 times x minus 2. So now when I I have log of base 4 on both sides, I'm going to put a 4, and so write those exponentially. And what happens is on the right side, or on the left side, it's just x, and on the right side is 3 times x minus 2, and now I can solve for x. So x equals 3x minus 6, and I'm going to subtract 3x, so that'll give me negative 2x equals negative 6. And then when I divide by negative 2, x equals 3. All right, in part B, we already have a log base 3 on both sides, so that kind of makes it nice for us. And just one of each. And so I'm going to come back and I'm going to put a 3 on both sides, which allows me to simplify that into x squared plus 3 equals 52. And I'm going to subtract 3 from both sides, and I get x squared is equal to 49, and if I simplify that, I get x squared equals 49, and x equals plus or minus 7. Now, when I'm doing the logs like this, I do want to check to make sure, am I going to have any extraneous values? So is there anything that I get that's not going to work? And just remember that you can't take the log of a negative. But if I put a positive 7 in for x, that's going to be 49 plus 3, which is 52. Or if I put a negative 7 in, that's also going to be 49 plus 3 is 52. So both of these will work. All right, the next one, we just happen to have a natural log, but we're not going to freak out over that. If you want to, you can make it log base e. So I can have log e of x plus 2 plus log e of 3x minus 2 equals 2 log e of 2x. So they're all log base e, but I really just want, if I'm going to have them, I need to only have one on each side. So I'm going to take the left side here that has 2 log base e's, and I'm going to combine them together, remembering because they're in expanded form, and put them together as multiplication. And so I have log base e of x plus 2 times 3x minus 2 equals 2 log e of 2x. Now this is a little bit tricky because if I just go at this point and I say, and I put a base of e, it's going to work great on the left side, but on the right side I've got this 2 in the way. So I'm going to bring that up and put that as an exponent on the 2x so that I have log base e of x plus 2 times 3x minus 2 on the left and log base e of 2x to the second. And I want to put that on the whole thing, not just the x. Now I can put my base e, and that's going to leave me with x plus 2 times 3x minus 2 equals 2x squared. And we're going to have to do some algebra. FOIL method, well, that'll give us 3x squared. Outer term is negative 2x. Inner is 6x. And the last is negative 4. And on the right side, we get 4x squared. Can simplify a little bit more. We have 3x squared plus 4x minus 4 equals 4x squared. Now the way this is set up, I'm going to bring everything over to the right side to keep my x squared positive so that when I factor it'll work out a little bit better. And so all of this here is going to come over to the left side, or the right side, and I'm just going to end up subtracting 3x squared from 4x squared, so that's x squared. And then positive 4x becomes minus 4x, and negative 4 becomes positive 4 equals 0. And now we can factor, and I get x minus 2 and x minus 2. So it happens twice, which would result in x equals 2. And you just want to check your answers and make sure that that works for the original problem. Is it okay if x equals 2? Well, if x equals 2 in the original problem, that's going to give me natural log of 4, so I can do that. Natural log in my second term, it's going to give me natural log of 4. And so everything should work out nicely there. So 2 is my answer. Okay, now this one, I mean, it's already kind of telling us that we're going to have some extraneous values. So we just want to watch out for that. I'm going to combine terms here because I have on this left side here, I have addition, and I can rewrite that as multiplication. So I'm going to have log base 12 of 12x times x minus 1 equals 2. And then I'm going to give a base of 12 to write this exponentially. So that leaves me with 12x times x minus 1 equals 144. And then we're going to distribute, so that's 12x squared minus 12x equals 144. And we've obviously got a quadratic. We're going to bring everything over to the left. 12x squared minus 12x minus 144 equals 0. I'm going to factor out a 12. And then really the 12 out in front there is not going to have any impact on my answer. So I'm looking at just this part, and I'm going to factor that. That gives me x minus 4 times x plus 3 equals 0, and the result would be x equals 4 and x equals -3. So we really need to go back up and check if anything is going to cause us to have a negative or a 0. If I put 4 in to the first term, that's going to give me 48, so I can do that. In the second term, that's going to give me 3, so I can do that one. If I go to put a -3 in, then that's going to give me log base 12 of -36, which is not going to work. So this guy is out. It's an extraneous value, and my solution is 4. So make sure you are careful with those that you don't have any extraneous values. Okay, guys, you do not have this assignment. You're going to do 3.4B practice, and you'll find those problems online. I will see you later. Bye.